Alrighty, so today I'm going to be discussing what is the bicarbonate buffer, what does it do in our body, and how to remember it. So I always kind of just drill this equation in my head here. So we have our CO2 plus H2O goes into, see it doesn't exactly equal, because this is reversible here, you can go back and forth into H2CO3, and again this is reversible into H plus HCO3. And now this is our bicarb here, and I'm actually going to draw this in blue to make a little bit more of a distinguishment for later. H plus HCO3. Okay, so this here is our bicarbonate in question. This always goes after this hydrogen ion here. This is hydrogen. And this is our carbonic acid. This is a combination of both of these facets here. So CO2 plus H2O can make this carbonic acid, and hydrogen plus HCO3 can make that carbonic acid here. Carbonic acid. Right? So carbonic acid is a very weak acid. It can split, kind of hates itself, as we always say. It can split into either of these. Now, this helps us control our acidity levels just throughout our body. Now, a good way to remember this is I split this up into two systems. This is our renal system right here. This is our kidneys, our bladder, and our urine. This over here is our respiratory. All right, so the main way we control our acidity levels is by getting rid of these hydrogen and the CO2. So naturally, if hydrogen and CO2 is higher in concentration, let's go up, it is going to equal acidic. If it is lower, it's going to equal alkalotic. So our primary method of lowering or raising our blood pH, say if it's too low, we have an excess of carbon dioxide or hydrogen, is by getting rid of it. Well, in both systems, we have a method of getting rid of hydrogen and CO2, and vice versa. So with the renal system, what we're going to be doing is we're going to be taking this hydrogen here and excreting it. We're going to be urinating out the hydrogen or excess hydrogen, and we are going to be, they connect. See, they go back and forth between each other. So this hydrogen here, or this bicarb, can absorb the hydrogen here, making our carbonic acid, which in our bloodstream, which would then split up into the CO2 and water. And now this connects back to a second method of how we get rid of it, which would be, we would breathe it off, right? We would get rid of this, get rid of our CO2, or not get rid of it, but lower our concentrations of it. This would therefore raise our pH and set us back on the right path. Now, the vice versa can occur. Fix this real quick. Hydrogen. And CO2. So let's say we have a deficiency in carbon dioxide or hydrogen, right? So we are very low in concentration. Our blood is very alkalotic, right? Well, since that would mean that we would have low concentrations of hydrogen and carbon dioxide here. So how would we fix that? We would retain those things to generate more of them through our metabolic processes, generate acids. So we would begin retaining these acids. So our renal system here would retain them by simply not excreting the hydrogen. You would urinate less. You would urinate less, which would cause your blood pH to go up. Now, with the respiratory side, it's pretty similar. You would retain CO2 instead. That would require you to slow down your breathing. Your breathing would slow down. You would breathe off less of that carbon dioxide. You would retain more of it into the bloodstream. This would lower the pH, causing you to be more acidic. This would keep us within that good range of acidity of 7.35 to 7.45. This is what we want at all times. Our body, through several buffering systems, one of the most important being the bicarbonate system, fights to keep this homeostasis factor at all times. So that's the basics of how the bicarbonate buffer system works.